Which,
Sir, actually today they have conducted NSO exam, sir. So in that physics, I have some three doubts, sir. I have
hmm,
sent through WhatsApp, sir.
okay, let me check that. An aeroplane has to go along a straight line from
Sir,
A to
not
B, and
sir, not this doubt, sir.
which one? Then it is you only, no? Yeah, you only. The last one, okay. This one, no, among them.
Yes, sir.
Two blocks are connected through a spring as shown when the system is released from rest. The spring was in natural length. Find the possible value. So this is something that I can solve it for you now, but it is not something that we have taken in class.
No, sir. Actually, it has been came in NOS exam, sir. I don't know how to solve it, sir. But
So
I
because
know
that,
it
that
came from last emotion, sir. That's why, sir.
we have done the laws of motion only, no? So it has got work on energy and concept of the collision also. So still I'll solve it if you understand it, or else you keep it for the chapter where it will come. So if I release the system, so what we'll have just before it will be hitting the 10 kg block will hit the ground, we can find the speed that 10 kg block will have. And it is told that collision is perfectly inelastic. It means after hitting the ground, the 10 kg block's speed will become zero. Okay, and it is going to fall through a high touch. So what we can do, mgh equals to half mv square. So speed will be root over 2gh, root 2gh. And just before it is going to hit the surface, the 10 kg and 5 kg block both will be moving with speed v. And just after the collision, the 5 kg block will continue moving with speed v, but the 10 kg block will come to rest. So because of this 5 kg block continued moving with speed v, it will compress the spring, then it will bounce back. And they are asking us the minimum value of the h so that the lower block can be lifted up. Now, it will compress that spring to what extent till the kinetic energy becomes zero, till whatever kinetic energy the 5 kg block has, all will be in the form of potential energy of the spring. And at the maximum, and then when it will be bounced, then what will happen? It will bounce back, correct? And it will reach a point when the spring will be in natural length, but the speed is going to be maximum. And again, it will continue going up till the speed it is having becomes zero and spring gets an extension x, and that will be the maximum extension, whatever was the compression when it was fully compressed, correct? And how much that kx max will be? Half kx max square will be equal to half mv square. And then at this moment, if at all this block is getting lifted, so what all forces are going to act on the 10 kg? Kx upward. Suppose the top block is of mass m1, lower block is of mass m2, m2g acting down. And for us to have no contact between m2 and ground, kx must be more than or equal to m2g, and x you can find that is our x max. X max is going to be our equal to m1 v square by k root over, correct? So you plug the value of the x and you can solve it, you will get the answer. Because we will be coming in terms of height only. Understood? You understood? Okay.
Yes, sir.
Otherwise,
Understood.
you wait for the chapter because other things are also there. Because the moment it collided with the ground, that moment the spring force we neglect it. Now, even if there is going to be any, because it is a non-impulsive force. So those things you can't think of right now. Next question to me. Ninth one after just this one, whatever it was.
Sir, after that, the question that you gave on class notes, sir, like that one
Mm.
type of question also there, sir. I can't solve it, sir. So I have sent
Just
through
a
also.
moment. That eighth one, that 11th one, no? Four blocks connected by a
Sir, yes,
string
sir.
like that. That
4 blocks element. That's sir. Yes, sir.
and that will try. That will try now only. Anyone having any other doubts, you message me while I discuss this. It will be easy for me if you'll send me the photos. It will be better for you also. So what we have is four block arrangement connected by light string. If the coefficient of static friction between the top and the bottom blocks is zero point 0.2 and the maximum value of horizontal force that can be applied to one of the bottom blocks that makes all the four blocks to move with same acceleration. Now, what I told you, first you assume all of them to be moving together. And then you see the motion of each one of them, especially the one for which the friction force is only going to be the force which will be driving them. Correct? So the moment, so what you do, you think as if friction was not present and how slipping will come into picture. That will help you decide how friction force will be applied on each one of them. Suppose if I'll take the S block on which we are applying that force F, so you can tell this surface is our leading surface. No? So the friction force, if I'll call it as F1, will be acting in this direction, and the friction force reaction of it on R will be acting forward. Correct. And for Q block, it also supposed to be moving in the same direction in which force F applied. So there must be some force coming onto it. That must be friction force F2. So its reaction F2 will be acting backward. Correct. Now you see the motion of Q is dictated only by the friction force. No? Now if I consider all of them moving together, so what is the common acceleration with which all of them will move? Will be F by 5 plus 5 plus 10 plus 10. No?
Yes, sir.
And it will be F by how much it is 20 and 30. Now F by 30. So this is the common acceleration with which it must move. Now F2 max is going to be equal to mu, which is 0.2 into that is 50. G, they have not told us what to take. So you consider it as 9.8. Okay, no. G did not is not given to us how much to take. 9.8 if I'll take, how much it is? 98 into 2, 196 into zero point 0.2. How much it is? Tell me. 1.96, no?
Yes, sir.
So this is our, even F1 max is going to be that much only, no? 1.96. Now, I want Q to be moving with that acceleration A. So the force that is making Q to move is F2 only. So F2 must be more than or equal to F2 max. So what we have F2 max as 1.96 should be less than or equal to F2, which is F by 30. So F must be more than or equal to 1.96 into 30. That is one thing we can have. Correct.
Yes, sir.
Next, you check out the other block, that is P and R. So I think this one only will give you the answer. Check that now. Multiply it and check that now. 1.96 into 30.
Sir, 58.8 is coming, sir.
58.8. Now we have to solve more a little bit. If the coefficient of static friction between top and the bottom block is 0.2. Now also I want the R and P block to move without slipping. So I have to check out for R block also. So what we have is, just a moment, if I'll take our, just a second. I will take our P and R as one system. So what we have net force in this direction is F1 minus F2. So F1 minus F2 will be equal to mass of P plus mass of R, which is 5 plus 5, 10 into A. So F1 will be equal to F2 plus 10 into A. And F2 is mass of Q into A. No? F2 will be mass of Q into A. Mass of Q is 10, so 10 into A. So it will become 10 into A plus 10 into A. That is our F1. So F1 is going to be 20 into A. So F1 must be less than the F1 max also. So if to check, no, if for making Q to move, I need 58.8, no, for making Q to move without slipping. But
Yes,
suppose
sir.
if making P and R to move, I need a lower force. Then that will be the force that will be the maximum force we must be applying. No? So here I have 1.96 to be less than or equal to, sorry, F1 is 20A. The 20A, which is F by 30, should be less than or equal to F1 max, which is 1.96. So F should be less than or equal to 30 by 20 into 1.96. 30 by 20 into 1.96 will be 3 by 2 into 1.96. It is 2.94. Just a moment, I might have done mistake somewhere. Just a second. 30, 1.96 only, na? 0.2. Sorry, I did not multiply that. No? F1 max is
Sir, we got
0.2,
58.8,
9.8.
sir.
Sorry, so 9.8 into 5. No, friction force is not 1.96. 1.96 into 5. How much it is? 1.96 into 5. 0.
9.8.
Just a moment. 9.8 into 5. 5 I forgot to multiply. 0.2. 9.8. Just a second. 0.2. 9.8 into 5. That is 9.8 only. So maximum friction force F1 is 9.8 Newton. That is wrong here. Need to correct it. So I'll solve it this one only. Maybe this is only going to give us the answer. So 20A should be less than or equal to 9.8. And 20 into F by 30 should be less than or equal to 9.8. So 9.8 into 3 by 2. 9.8 into 3 by 2 will be 4.9 into 3. That will be 14.7 Newton. F should be less than or equal to 14.7 Newton. Maybe
Sir,
they have
so the
taken GS
answer is 15 in, sir.
15 Newton because they might have taken GS 10. That's why I took GS 9.8. Okay,
Okay,
if
sir.
I'll take
Now I got it.
GS, I'll take it as 10, then answer will come 15.
Okay, sir.
Understood now?
Thank you. Yes, I understood, sir. One
More,
minute, sir. I
more,
will copy this, sir.
okay, no problem. SC Verma and LLM question number.
Sir, copy it, sir.
Question number 31, 35 laws of. This one, American, this one. So you draw the, see, first of all, you assume some direction of acceleration for them. And you can tell this may be coming down. Suppose it comes down by A. So for the string to be taut, it must rise up with A. And this must also rise up with A. No? Tension in the same string, here if I take T1, suppose, here it will be T1. But just after this block, tension will not be same no? Because I have a block. Tension is same in the string. One reason is mass is not there. So in between the connection of the string and the string, I have a mass placed in between. So it's not going to have tension same that we can tell. So T2 here. So our 50 grams, suppose I'll name it as M2. This one I'll name it as M1, and this one I'll name it as M. So what we have is for our M2, if I draw the FBD, T2 upward, M2G acting down, going up with A. So T2 minus M2G equals to M2A, equation number 1. For our block kept on the incline, T1 upward, T2 down, component of mg down the inclined plane mg sine theta normal contact force, this way mg cos theta, it is going up the inclined plane with a. Another equation will have T1 minus T2 minus mg sine theta equals to ma. And for the last one, we have m1g acting down, T1 upward, and coming down with A1. So we have M1G minus T1 equals to M1A1, M1A, coming down with A only, not A1, all moving the same acceleration. So what we have got is three equations, and the unknowns that we have is T2 we don't know, T1 we don't know, and A we don't know. So three unknowns and three equations. After this you can solve. Understood? No?
Sir, I have a doubt, sir.
Tell me, no?
Sir, here it is T1 minus T2 plus mg sin theta, na, sir?
No, no, minus mg sine theta. Mg sine theta also
Sorry, plus.
acting.
Sir, because T2 and mg are towards same direction, na, sir?
Dude, how T1, T2, T1 upward, no? T1 upward, T2 down the inclined plane. Mg sine theta also down the inclined plane. I am taking my net force in the direction of the inclined plane. Got it now?
Okay, sir, now I understood, sir. Now I understood.
Okay, okay. Next out, tell me. Any more doubts? Rupesh, any more doubts? How was the paper? Paper easy or difficult?
Mostly easy, sir.
It was intentionally made easy.
Sir, for the friction part alone, the things that you teach only came, sir.
I told friction just beginning will come, entire friction will not come. And friction, many of the things will be there in the upcoming chapter. And I'll be going beyond the level of the exam, any exam you will write. So don't compare the exam with our class. Our class may be more difficult than the exam question. Exercise one. Exercise one. Which chapter? One? Exercise one. Laws of motion. Which module? Don't have all the modules with me. Can you send me the question if possible? It will be easy for me then. Maybe somewhere, but I don't know where I might have kept it. I don't have the module. Send me the question, Amir Khan. In WhatsApp also you can send. For anyone who is having module in front of them, they can also send. Not like we will only send. Okay, so what we have to do is, so you sit in the frame of this carriage and you draw the free body diagram. Okay, and if you do that, you will be having one normal contact force applied on our sphere by the surface AB, and that is going to be this one. And if I draw any normal to a circular or a spherical object, it will be passing through the center. And the normal contact force, to draw that, first we draw the common tangent. So for surface AB and the sphere maintaining contact, the surface AB itself is the common tangent. So whatever drawn normal to it at the point of contact will be our common normal. So what we have is, I'll take components of these two forces. So what we have, the angle between the horizontal and the AB is 30 degree. The angle between the normal drawn to AB, which is common normal along which the normal contact force acts, and the horizontal will be 90 minus theta. So this force, which is NAB, it is making an angle of 90 minus theta. So what we have got components here is one will be upward, one will be in left rightward direction. So one which is in the rightward direction will be NAB sine theta, and one which is in the upward direction is NAB cos theta. Correct. Then the normal contact for force from BC will be in the horizontal direction that you can tell now. This will be our NBC. And the frame from which I'm observing is by sitting in the wedges frame, and it has got acceleration A in the leftward direction. So we'll have to apply pseudo force in the rightward direction, which will be MA. Now, if I'll check out the forces acting on our object along horizontal and vertical, so we have NAB cos theta acting upward, MG acting down. So what we have is NAB cos theta must be equal to mg. So what we have is NAB must be equal to mg by cos theta. Theta not changing, mg not changing. So NAB will remain constant. And then what we have got along horizontal is NAB sine theta this way. And we have got NBC this side. And we have got pseudo force which is acting this side now. So what we have is MA equals to so MA and NBC. Just a moment. MA is rightward direction, and our NB sine theta is rightward direction. So MA plus NAB sine theta is going to be equal to NBC. Now our NAB is constant, so this term is constant. But if I increase A, then this entire thing will increase, and because of which our NBC will increase. So what we have is NBC increases and NAB remains constant. NAB remains constant and NBC increases. Understood now? Amir Khan. Understood? Okay, then next out will be okay, yes, I've got class from 5:30. Okay, so I'll end the class here only. Tomorrow also, like this, I'll keep the class 4:30 almost. 4:45 you take it. Okay, in case if I don't send you the link, you message me, then I'll send the links. Okay, in case. Okay. Okay, then bye everyone. See you in the next class.
Thank you, sir.
Thank you, sir.
Year 2020. See, what we have is we are going to use the same thing, that is total length of this thing will remain constant. Okay. So suppose if I have a pulley and this is the string that we have on one side, this is the string on the other side. And if I happen to know that this point, any point on the left side is going up with V1, suppose, and any point on the right side is going up by V2, and let's suppose it is given that pulley going up by Vp, and we need to relate Vp with V1 and V2. So what we do is, in whatever direction they are provided their velocities, you consider displacing them in those directions. Maybe I'll give the name to the points here. So this is A, this is B, this is suppose yeah, maybe this is suppose A, this is B, this is C, this is D. There is center, maybe I'll call it as O. So what I will do, I will displace the point. Suppose the point A given velocity upward. So I will displace the point A in upward direction by some amount. Suppose point A comes to A dash, and in doing so, it moves by an amount x1, suppose. Just hold, maybe I'll zoom it a little
Yes,
bit.
sir.
Then what I do is I move, since given that pulley going up, so I will displace my pulley, okay, to by, and if pulley goes up by an amount xp, so tell me the string on the either side must increase by xp. No?
Yes, sir.
So what I'm considering is that if pulley goes up by xp, so string on the other side will end up increasing by xp. So this point C will end up going to new point C dash, D will end up going to new point D dash. The same thing I'll do
B
that.
will also go to B dash, sir.
So yeah, B will go to B dash, and that is going to be suppose goes up by x2. Next, what I have is the length of the string in total that I have on left and right all together will remain same. Whatever amount it gets reduced on one side, same amount it will end up increasing on the other side.
Yes, sir.
Correct. So what I can do is I can write down that A B plus C D, sorry, not A B plus C D, A C, the string on the left side. Okay, maybe I will call it as L1, okay.
Okay, sir.
And this one I will call it as L2. The string that I get to have on left and right after considering those displacements, suppose it is L1 dash plus L2 dash.
Okay,
Now, what
sir.
do you see? What happened to our length now? Because of A going up, it has been reduced by x1, the length on the left side, and because of C going up, it has been increased by xp or not.
Yes, sir.
So what we have is I'll write down L1 plus L2 is going to be equal to L1 dash plus L2 dash, and what we have is L1 dash. I'll write down as L1 is going to be increased by xp, reduced by x1. That is our L1 dash. Similarly, you see that because of B going up,
L
our
to
length on
P
this side will
is
reduce by x2. Yeah, correct.
minus X2.
L2 plus xp minus x2. And that is same as equal to L1 plus L2. So I'll simplify cancelling out this two. We get xp to be equal to x1 plus x2 by 2. No?
Yes, sir.
Simplify it and you will get this is what it will become. Then you differentiate it, I'll get Vp to be equal to V1 plus V2 by 2. Then again I differentiate it, I'll get AP
Okay,
to
sir.
be equal to A1 plus A2 by 2. So in general, what I tell you is, we consider writing down XP to be equal to plus minus X1 plus minus X2 by 2, VP to be equal to plus minus V1
Yes.
plus minus V2 by 2, and AP to be equal to plus minus A1 plus minus A2 by 2. When to use plus, when to use minus, we will see in next example. I'll say this thing, so no need to copy. Okay,
Okay, sir.
next, I'll consider taking velocities in little different manner, and we will do the same exact derivation, the one that we did earlier. Or you try doing that. I'll tell you what way to
Okay,
write
sir.
it down. So what's just given? This point on left side going up, this point on right side going down, and the pulley going up by Vp. So what do you see? These two are in same direction, and these two are in opposite direction. So the one
Correct.
that are in opposite direction, you consider putting minus
Like
in front of it. This one plus. So what we have is xp equals to
XP.
x1 minus x2 by 2, right? No? Vp
Yes,
equals
sir.
to V1 minus V2 by 2, and AP
From
equals to
previous
A1
equation,
minus.
directly we can apply, sir.
Yeah, then how to derive it? This way only.
Okay, sir.
And then whichever way you derive it, that pattern will emerge that whichever side, whichever are in same direction, V1 same direction as VP. So in front of V1 I have plus, and
Okay, sir.
V2 opposite to that, so minus. So like that, that pattern will emerge. Now,
Okay, sir.
where to use this thing? Wherever you see pulley moving, there you can use it. For example,
Okay, sir.
suppose if I take this case, where I have this one we have done, maybe I'll draw it properly. I'll take a new page, okay, there I'll draw it.
Okay, sir.
This question we did in the class, simple one only, just I will do it by this way to give you the idea how we are going to apply this thing in actual questions, wherever you are going to find a pulley which is going to be moving one.
In polymer system, the pulleys will be
Pulley is
maximum
more.
moving only, right, sir?
Just a moment. Just a moment. Just I'll try to understand. So this is M1. This is M2. Okay. Now with whatever acceleration our pulley will come down, the same acceleration our M2 will come down. Okay. Now suppose if I consider a point on the string here, and if it is going to be moving with V1, then the amount by which the string will become loose, that much amount it is going to be given to the other side. So this side it will be coming
Yes,
down
sir.
by V1.
Yes, sir.
Now the point here you see this one is fixed now. So this point, any point on the string on the other
Yes, sir.
side
That point is
will
fixed.
be coming 1 0. And if I consider this block coming down by V2, so what I can do, I know that one point on this side is going down by 0, this point going down by V1, and this one going down by V2. Now, pulley velocity is V2 now, so this two is same direction, so positive. So V2 will be equal to plus V1 plus 0 by 2, so V1 equals
So
to
it is in
2.
any direction, but if all directions are
Yeah,
same,
yeah,
that will be
yeah,
equal
yeah.
to.
Same means plus. Yeah, same. I told same
Okay,
direction.
sir.
So A1 equals to 2A2. And this will be the constant equation, fourth equation you can write easily. That I write down T1 equals to M1A1. And here if I consider T, here if I consider T, here it will be 2T going down with A2. So it will be M2G minus 2T equals to M2A2. 1, 2, 3 equation 3 and 1 equals 1. Understood?
Okay, sir.
So some of the students might have taken the notes. So after this, I have discussed questions only. So you try taking out with them. Okay.
Okay,
Just one more thing I will tell you that has got the use of this
yes.
one. Other ways are also there, but this way it is more easier to solve. So this question I think came in exam also, or it is something like this. Similar kind of question came. I might be trying a little bit different, but concept same. Improperly handled understanding. So this one given M1, this one given M2, this one given M3. And we need to find the acceleration of each one of them. So what I will do, I'll assume whatever I want to assume. Maybe I'll assume this M1 going up by A1 as I see from ground frame. And if M1 goes up by A1, then this point on the string will be going down by A1 only.
Yes, sir.
And then I assume that this M2, I'm assuming it may be wrong. I am assuming M2 going up by A2, M3 going up by A3. Here tension is T, here also it will be T. So here I am going to have T by 2, here I will have T by 2. And depending upon what we have considered the direction that they are going to have, accordingly I will write the free body diagram. I'll draw the free body diagram. I'll write the force equation. So I'll do it directly. We will have T minus M1G equals to M1A1. Then T by 2 minus of M2G equals to M2A2. And M3G minus T by 2 equals to M3A3. Equation number 1, 2, 3. And we don't know T, we don't know A1, we don't know A2, we don't know A3. So we have got four unknowns and we have just three equations. So we'll need one more unknown.
Yes,
And
sir.
that will come through the constant equation. So what we have done is whenever you see moving pulley, you can apply that moving pulley constant. So what we have considered the pulley going down by A1. Point on this side will be going up with whatever M2 going up, A2. Point on this other side will be going down with A3.
Yes, sir.
So what I have is all these two in same direction, sorry, these two in opposite direction, these two in same direction. So
Oh, yes,
pulley
sir.
acceleration will be equal to A3 minus A2 by 2, equation number 4. Four equations, four unknown, now it is ready to solve it somehow. Understood? No? Correct. And there may be some other
Sir,
questions I
now
need to
we
do.
know the value of A2, A1 now, sir.
So I have got four equations, four unknown, no?
Okay, sir. So with
So you
this,
can
we
solve
should
it.
apply in this and find out the other
No, no,
values.
after no physics. After this you can solve or not. Four equations, four
Ah,
unknown.
yes, sir.
No, no, okay.
Okay, sir.
Okay. Any doubt?
No, sir. Thank you, sir.
You solve the module as soon you can solve it. No?
Okay, sir.
Okay.
Thank you, sir.
Okay. Okay, rod of length L. You rotate it about one end, and they are asking us tension at, you know, at this place we have to determine tension and at a distance of 3L by 4. Simple. No? What we will do, one thing you can do by integration, correct, and tension we can say, suppose if I'll take things up till here, so whatever masses I have beyond this extent is undergoing circular motion. Some things will be providing for the required centrifugal force. So there must be some net force acting on them altogether. No? Or you think in terms of center of mass also. So if I'll take this much portion as our system, or whatever I have this side, the center of the mass of that system is undergoing circular motion. So it has got some external force acting on it in that direction. So what force will be tension force only? So if I take some length and whatever length will decide what will be the different points will have different tension that we agree to that. So and we can also say the tension will change with the distance from the center. So what I will do, I'll consider tension to be a function of r, and at some distance r, suppose the tension I consider it to be t. So if I change r to r plus dr, the tension will change. You don't know that change will be positive or negative, just will consider it will change. So T will be changed from T to T plus Tt. So if I consider a strip whose one end is at distance r, other end is at distance r plus dr, so tension at this location we have called it as T. So here we are going to have T plus dt, and whatever tension may be at any point, it may change with change in point, but still at a point it will act in action reaction pair in a manner to try to elongate that section onto which we are applying it. No? So maybe I'll draw the free body diagram of the left side, this small differential element that we have taken, and the remaining other side. So here tension, whatever I have, if I draw that, tell me, is it not going to be in this manner? No? So here I have T, here it is T plus dt. So same we are going to have here T, its reaction. Correct. Now why I have taken a very small element, tell me. Any reason to take a small element? Not visible. Amir Khan, if you have doubts, send me on my WhatsApp now. The photo of the question, then I'll. You have my WhatsApp number, I think so. Or even here also you can send. Or if you came to listen to doubt class, you can listen that is also okay. So why I have taken a small element? Any idea? Because the thing that it is doing is going around in a circular path. So for and only thing we know is to calculate the centripetal acceleration of point mass only. That is what we know. That's why we are trying to make the system for the thing for which we can analyze it, for which we know what to do. Right? So we think of the system made out of something for which we know how we do the math or physics regarding that. The only thing we know right now is we don't know how to deal when I have more than one particle. No? Till now, we are going to do things where I have one particle, we are considering about system of particles is next chapter or not, central to mass chapter. It means only thing I know to write down force equation for point mass, so I can think of it is made out of infinite number of point masses. That is the reason I have done that. Because I know how to write the centripetal acceleration of point mass only. I don't know how to write down for something which is not a point mass, like this rod. So what we see is from ground frame, this point mass is supposed to have an acceleration inverse, and mass suppose it is having is dm, it has got centripetal acceleration inverse omega square x because very small omega square r, so it can be considered to be located at r only, no? Correct. So what I have the net force acting, so t this way, t plus dt this way. So net force this side is minus dt basically, no? Because dt is change in tension, it can be negative also. We don't have to worry about that. So minus dt is the one. What we do, we find net force that acts towards the center. That will be the one that will be providing for what centripetal acceleration. So it is like acceleration only. Suppose if I have a block being pulled with an acceleration, what do we say? Whatever net force I have in this direction is the pulling force, and that is whatever way we'll find the net force in that direction. So net force in radially inward direction is minus dt, so that must be dm omega square r. And then what we do, we write down dm. So for length L mass is m, so for unit length mass will, so for dm will be, so minus dt becomes minus of m by L omega square r dr. Then we integrate both the sides, but what to plug the limits? I need to know tension at one place at least. No? We don't know what tension here I have, but we know what tension once I don't have any material, what tension will be. So tension at x equals r equals to capital L is going to be zero, and tension at some place r is supposed to be. So using this, we can find tension as a function of r. Then you can determine what tension we are going to have at any location. Understood? No? Amit Khan, you may not be getting it because this is not started in your class. Okay. Next, tell me. What doubt you have, tell me. No? Just a moment. No doubt, no problem. You can listen to the doubts. These are something that will come later on. Next doubt. पहले एक्सरसाइज 5 बनाओ, उल्टा बना रहे तुम लोग। टाइम कहाँ है? एक्सरसाइज 5 डायरेक्ट एक्सरसाइज 5 के बाद उल्टे चल लो, छूटेगा तो बिगनर पर छूटेगा, छूट जाएगा दिक्कत नहीं। सब इजी क्वेश्चन है, वो थियरी ढंग से पता, सब इजी है। ये लो ना। अच्छा ये क्वेश्चन कंजर्वेशन मोमेंटम आ जाएगा उसमें। अच्छा ये बताओ जरा, पता होगा मैं भी, इजी चीज है। मान लो दो कंसेंट्रिक स्फीयर है जिसके बीच में इन बिटवीन देम द गैप इज वेरी स्मॉल, and we are dropping a ball which is just fitting in between them and can slide without any friction, and we are dropping a ball from the topmost position. So and we consider that inner radius outer radius almost equal, and you can take it as r. So can you determine, suppose inner sphere I'll give the name as a, outer sphere I'll give the name as b. So I can send the photo, no problem. You follow CV, you follow, you solve Allen module, then you follow any book, no problem. And for reading theory, first read from H.C. Verma, Ali Drisnik Walker, then if you have time, read for any book, no problem. But minimum requirement you must do, then you do any book. Okay? India is not bad, but so many questions you will not be able to solve. And many questions repeated only. So first you solve the module, then you solve any book. And if you find some question that you know how to solve, don't solve it again. Solve the ones that you think that are different that you may not be able to solve. Okay. So if you have doubts, you send me on my WhatsApp. It will be easy so that I can just test it here and then I'll discuss it. Okay. So can you determine the variation of the tension as a function of theta, the one that it will be, the variation of the normal contact force with respect to theta, the one it will be having between with A or B. Looks familiar only, no? So tell me, is it at any point of time it is going to make contact with both of them? No, no. Just little gap, maybe one atom thickness gap, but there's a gap. So every time the point mass will not be sitting on a sphere A or may not be having contact with the sphere B. Both contacts will not be happening simultaneously. So at the time it will be in contact with one only. And in the beginning we can tell it will be in contact with A only, no? And that you might have done a point where block slips off, cos inverse of 2 by 3, no? If I drop a ball. So what will happen till the time point it will be in contact with inner one. And once that contact lost, it will go outward. Why it will go outward? You can sit in that frame and you can think like that. Centrifugal force outward if it increases to a certain extent. Or from ground frame, how you will tell? Telling from centrifugal force easy, no? Suppose if I'm going around in a circular path and then friction force is the one providing for the required centripetal acceleration. So if I'll sit in the frame, then it's easy to say centrifugal force outward. So it keeps on increasing, and if it becomes more than F max, then it will slip. But what the argument you will tell once I am in ground frame? Any question you solve it from both the frames. Don't not just in that frame, whichever you find easier. So what we say here is that if I have got so from ground frame I will see centripetal acceleration. It is supposed to have this way. So what force may come? Friction force will come. The friction force should be equal to omega square or mv square by r. Now suppose if I apply that mv square by r, I move it to some speed such that it becomes more than F max, then no one is there to provide for the required centripetal acceleration. So it will adjust the speed and not decreasing. So what it must do to reduce mv square by r, radius must increase or not. That's why it will move outward. Understood? Me? Right? Same here. Correct. Till some point it will be in contact with the inner one, and beyond that it will be contact in the outer one. And then you can also find n as a function of theta also. No? So you will be writing it down as normal contact with A is going to be equal to whatever you find as a function of theta when theta is less than the angle theta naught where it loses contact. For angle more than theta naught, it will be 0. Same way. And B will be equal to 0 till angle is less than or equal to theta naught, and beyond that some other function of theta for theta more than theta naught that you can find by writing down the force equation in the radial direction. Any more doubt? Some- American, any doubt? Any personal doubt you can also ask.